Good day, students. This is Summer School Lesson 2-6, and I hope you enjoy the lesson. Let me get started. Okay, today's lesson 2-6 is on page 130 in the textbook, and it's on rates, ratios, and conversions. Okay, first let's go ahead and get started. I want to give you the definition of a ratio. A ratio is a comparison of two numbers by division. Let me say that again. It's a comparison of two numbers that are being compared by division. Okay. Now, those mathematic words sometimes are hard to understand without an example. So I want to say there's three ways to write a ratio. Okay. There's the standard way to write a ratio, which is 1 to 2. And I use the word 2, T-O, but I said 2, but I used the colon to represent that. That's the standard form of writing a ratio. The written form is 1, the word 2, and then the other number, 1 compared to 2. And then there's the fraction form, 1 to 2. Now, you notice I said it like a ratio. I said 1 to whatever the second number is. But in the fraction form, it's written like, it looks just like a fraction, okay? So standard form is used usually when you're presenting ratios, like if you just are saying, okay, this is 1 to 2 here. In text, sometimes you might use the written form, but when you are doing operations with ratios, generally that's when you're going to be using the fraction form, because the fraction form is going to be a little bit easier to manipulate and add or subtract, things like that, reduce or increase. A little hint here, ratios in fraction form work the same way as fractions in how you multiply, divide, add, or subtract, also reducing and increasing. So essentially, a fraction is just a ratio. The difference is with an actual fraction, the ratio is comparing part to whole. With a ratio, like just a standard ratio that's not specifically including partial numbers, a ratio is always comparing a number to a number. For example, in the fraction 1/2, 1 over 2, I'm comparing one part that is here to two parts that exist. Let me say that again. There's two parts that exist, but one of them is here. With the ratio 1 over 2, or 1 to 2, notice I said it differently. I didn't say 1/2, I said 1 to 2. I have the whole number 1 comparing it with the division bar to the whole number 2. So even though as numbers, ratios, and fractions may look the same, the ratio 1 to 2 is comparing one thing to two things, where the fraction 1/2 is comparing one part to two parts. Okay? Now, I don't want to confuse you with this, but since a fraction is basically a ratio that always compares parts, okay? Ratios can also compare whole numbers, okay, by themselves, but a fraction is a special ratio that compares parts. Hope that's clear. Now, if you're taking notes right now, this might be a good time to just pause and just finish up your notes on ratio before we go to rate. Okay? So we're going to go to rate right now. Now, a rate is a specific ratio that compares two quantities or two systems of measurement. Okay? Now, again, just want to say that some of these definitions sort of like go into each other. Like I had said before, a fraction is a ratio, but a ratio is not necessarily a fraction. Okay? So in this one, the word ratio, which is kind of the blanket term we're learning, has a different application where it's called a rate. Sorry, this is my cat. She has a tendency to jump up here when I'm trying to get work done. Okay, let me get this back to normal. She comes for your entertainment. So anyways, the ratio 1/2, or 1 to 2, is simply just comparing these two numbers. But the rate 1 to 2 is comparing two things. Okay, for example, I could have one tutor for every 2 students. Okay, that would be a really good rate of comparison, or like, the students would be able to get a lot of help. Or there's 1 yard for every 2 seconds. Like if someone is like in a brisk walk kind of a competition or something. Now, you'll notice with both of these, I'm comparing two different measurements. Now, I'm comparing yards to seconds. Okay, that's a rate. And this one is not specifically a measurement, but it's just two different things. One tutor, meaning someone to teach or instruct on something, compared to every 2 students. Now, I want to go into what a unit rate is. Okay. A unit rate is a rate with a denominator of 1. Okay. Now, let's take a look. Here's a rate. Let's say that there's 12 students for every 4 tables in a specific school group setting. Okay. A unit rate would be that there are 3 students at every 1 table. Now, this is the same as the rate. If you were to take the rate here and reduce it, let's see. So that would be divided by 4, divided by 4. 12 divided by 4 equals 3. 4 divided by 4 equals 1. So essentially all I did was I took the rate, and like a fraction, I just reduced it. 12 students to 4 tables becomes 3 students for every 1 table. So a unit rate, the idea is you want to take your, you want to make the denominator, the second number, and turn it into 1. Okay, this time I'm going to go ahead and pause so that you can get all of that written down. Okay, hope you had a chance to look at everything. Now I'm going to go ahead and share with you again. This is next page of notes here. In lesson 2.6, I wanted to go over some of the problems. Now, the problems I'm doing and definitions are actually on page 131 in your book if you need to review them. They're the same problems. But I'd like to do them and have you sort of like walk through the steps. Now, there's a unit rate here, a unit rate problem here rather, problem 1. The problem was this. There are 3 different stores. They gave them random names of A, B, and C. I guess that's not random, but it is sort of like not very creative. Anyways, so these 3 stores have a sale on t-shirts. Store A has 2 t-shirts for $25. Store B has 4 t-shirts for $45. Store C has 3 t-shirts for $30. Who has the best price? The best price you can find with the unit rate, okay? And again, the word unit comes from the word uno, which, as you know, means 1, okay? So basically what it comes down to is what is the price per 1 item, okay? So I have my ratio $25 to 2 shirts. It's written in fraction form, 25 over 2. So 25 over 2 means 25 divided by 2. Okay, so that would equal $12.50 per shirt. So as a ratio, you would write it like this: 1250 over 1. Now it is a unit, okay? Remember, to make a unit rate, you're just changing your denominator to 1. How do you do that? The steps are very simple. Divide the numerator by the denominator. When the denominator goes into the numerator, the denominator automatically reduces to 1, okay? Now, whatever the numerator becomes is just a work of the division. 25 divided by 2 happens to be 1250. Okay. Now I have 45 divided by 4. And that's 11.25. So the answer would be $11.25. Now, to write it as a unit rate ratio, you would write it like this: 11.25 over 1. Okay, remember, to be a unit rate, the denominator has to be 1. Now you notice when I wrote the answers, I did not write them over 1, because as you know, anytime you have a fraction, which is basically a ratio, and the denominator is 1, then you can just write it as a whole number. Okay, so even though I'm writing them as a unit rate here, just to show you the work we did, I'm writing them as whole numbers for the answer, because the answers we're looking for are whole numbers. Okay, so now I have $30 divided by 3 shirts. So we go 30 divided by 3 is 10. So that would be $10 per shirt. Now I would write it as 10 over 1 to put it as a ratio, but again, I want to write my answer as a whole number. So to answer the question, who has the best price on shirts, store A, B, or C? Yes, that's right, Evelyn. It would be store C, $10 for the shirts, or $10 per shirt. Now, let's continue on with lesson 2.6. Now, this lesson's on page 131. I'm going to go over the words conversion factor. Conversion factor is a special ratio between two measurements, or a specific ratio. Now, there's a table on page 649 if you want to check that, and that is special conversion factors that are commonly used. Now, these words are a little bit dry in explaining it, so let's just go to the examples. In this case, 12 inches is 1 foot, so the conversion factor would be the number 12. That's how many times an inch goes into a foot. So if I'm converting from inches to feet, I would need to use 12. Okay? So if I had 2 feet and I said, well, 2 feet is how many inches, then I would have to say, well, that would be 24 inches. Okay? So I would get my answer by just multiplying the number 2 times the number of inches, or inches per foot. Take a look at this one. So 100 centimeters is equal to 1 meter. So the conversion factor would be 100, okay, because 100 of these fits into one of those. 5,280 feet is equal to 1 mile, okay? So again, the conversion factor is just the number of how many of one thing fits into another. Now, in the previous examples where I said like how many tutors per student, or how many students per tutor rather, those are real things that we can use ratios for, but those are not systems of measurement, tutors versus students, okay? So if a system of measurement is not being used in the ratio, then you probably would have no need to convert it. It's only when you're converting from one system of measurement to another, okay, that you would need to do a conversion. Now let me say this too. A lot of times you have systems of measurement where it has a rate, like, for example, miles per hour. A car is driving at 60 miles per 1 hour, 60 miles per hour, okay? Or as most people would say, I'm doing 60, okay? Now, in a situation like that, um, if there was a need for a conversion, then it would have to convert to another system of linear measurement. For example, I can convert it to feet per hour, or I convert it to yards per hour, okay? Things like that. Um, but I can't necessarily convert it to like another nonlinear measurement. Like I can't really say like grams per hour or pounds per hour because that's a completely different form of measurement. It's not linear, meaning that a linear measurement is something that measures a line. Now let's say I want to convert miles to kilometers. Well, kilometers is linear, it's measuring something in a line, and miles is linear, it's measuring something in a line. Okay? So that can be done because I'm converting from one linear to another linear. Okay, I'm not converting it to like a measure of like weight or something like that. So just a little extra information there. All right, so let's take a look at problem 2. I want to show you the steps for doing this type of a problem. I wrote the steps down here on the bottom of the page. I probably should have written the steps first, but let's just go over the steps and then we'll do a couple of problems and then I'll review the steps. Step 1 is you want to cancel common units in the numerator and the denominator. Step 2, you want to multiply the fractions using 1 as a denominator for whole numbers. Step 3, divide or multiply. Those are usually the two steps that are required in order to find a unit conversion. And step 4 is write the answer in the remaining unit, or the unit that you're looking to find out about. Okay, the steps don't make much sense unless you actually see the problem. So here's problem 2 on page 131 if you want to look at it in the book. But it's split into two parts, part A and part B. Here's part A. The question is 330 minutes is equal to how many hours? So first, you want to set this up as a math problem. To set it up, you take the whole number 330 minutes times the conversion factor, which is 1 hour for every 60 minutes. Okay, so it's a whole number here times a fraction. Okay, the first step, it says to cancel common units in the numerator and denominator. So the units means the words that I'm counting here. So first I'm going to write this as a whole number. I think I said that here. Use 1 as your denominator for whole numbers. I just did it first on this one. I normally would do that second, but just to show that I'm counting this whole number sort of like a fraction. So, since I have minutes in my numerator here, and I have minutes in my denominator here, I'm going to cross-cancel them. By cross-canceling them, I'm showing that the thing that I'm trying to find is hours. So step 2, multiply the fractions. So I have 330 times 1 is equal to 330. 1 times 60 is equal to 60. So I have the ratio 330 over 60. Now it says that a ratio is comparing by division. Okay, so I'm going to go ahead and divide these. My first step, since there are common zeros in the numerator and the denominator, I'm going to cancel those out. It's just like an easy way of reducing. Okay, so now I have 33 divided by 6. 6 goes into 30 5 times. 5 times 6 is 30. 33 minus 30 is 3. I'm going to annex a 0 and bring it down. 6 goes into 30 5 times. 5 times 6 is 30. My problem cancels. So my answer is 5.5 hours. Now, you can say that a few different ways. You can also say 5.5 hours. Or if you want, you can say 5 hours and 30 minutes, since you know that 30 minutes is a half an hour. Okay, so I just want you to see how you got that. So let's follow the steps again. Cancel common units. So minutes and minutes are canceled, leaving us hours, because remember, hours is what we're trying to find. Okay, multiply the fractions. Make sure they use 1 as a denominator. So I multiplied across 330 times 1, and then 1 times 60 is equal to 330 over 60. I simplified, which you don't necessarily have to do, but it just made it easier in my mind, to 33 over 6. By the way, you can only cancel zeros if they're common and if they're the last digit, meaning the digit furthest to the right. Okay? So like if I had, let me just show you, just to avoid common mistakes. I have 1,000 divided by 30. I can only cancel 1 0 on top and 1 0 on bottom. I cannot cancel these other zeros here, okay? And the reason I can't cancel those zeros is because they are, they're not common in terms of the top to bottom ratio here, okay? Hopefully that makes sense. Okay, so I want you to see how we got the answer here. Again, 330 minutes is equal to 5 hours and 30 minutes, or 5.5 hours. Okay, let's go ahead and take a look at question B. 15 kilograms is equal to how many grams? So in this case, grams is what we're looking for. So let's go ahead and write grams as your numerator. Okay. Now in my conversion factor, since the thing I'm looking for is my numerator, then the other thing is going to be my denominator. So the question is, how many grams are in a kilogram? There's 1,000 grams in 1 kilogram, just like there are 60 minutes in 1 hour. Now you'll notice on this one, since hours is what I was looking for, I wrote hours on the top. But since grams is what I'm looking for, I wrote grams on the top. Okay? So the question is, it's not so much does the smaller unit or the larger unit go on top? Okay? In this one, I put the larger unit on top. In this one, I put the smaller unit on top. The one that goes on top, or is the numerator, is the one that you're looking for your answer. Okay? The opposite one is the denominator. So whatever the opposite one is, I don't care if it's the larger one or the smaller one, the one that you're not looking for becomes the denominator. So let's follow the steps. Cancel common units, kilograms, kilograms. Now I want to remind you, you can cross cancel when you have two fractions that are being multiplied. It's a way of simplification. So in this case, when I'm canceling, I'm not actually canceling numbers, I'm canceling the units, okay? Don't think of kilogram as like a variable, but it's an actual, thing that we're canceling out because we're trying to find grams here, okay? So now we multiply across, so 15 times 1,000 would be 15,000. 1 times 1 is 1. Okay. Step 3 is divide or multiply. In this case, 15,000 divided by 1, it's already written as a unit rate, so I don't have to divide. I would just write my answer in the remaining unit. And my answer is 15,000 grams. Okay. Hope that made it clear, and I hope that you're enjoying Math Summer School. Thank you.